Okay, so what I did was I wrapped the battery around the surfaces. That's the reason why the material right there, that's the soft battery, similar to the batteries that go into a phone charger. So I wrapped it around the sphere. It's coupled to a copper coil. I have wrapped the uh, the iron sphere, stainless steel sphere with winding coil. I wrapped it 2 times. I put capacitors, coin capacitors is right there, right on it, right over it. This touches the metal part in phases, the external, so it's a step up. First comes the capacitors, which is the coin capacitors, where they have one phase for positive and negative on the upper. So that's touching against the stainless steel. And then the coil is wrapped around it. The wire is phase and the wire is taped, the phase coin is taped to the surfaces of the stainless steel. So that should flux the stainless steel, separating the parts, to whereas the capacitor phases the stainless steel. Then the capacitors are wrapped in a coil, but the top of the capacitor is phased with a tape, metallic tape, conductor on the outside. And that touches against this surface that is separated from this surface. However, these two surfaces are joined together in the under, but the over, this battery, see the phase point of this battery? The phase point of this battery of the conductor, the metallic is, this is the metallic for the phase upward, and this is the metallic for the phase downward. In this phase, these two separate parts that are separated. I'm going to use tape to separate this part, and then tape to separate that part, and then I'm going to go over it with another foil to cover that part, and then I'm going to go over it with tape. The idea, I'm going to set one side with silicon carbide, I'm going to mix it in a resin, and apply that from the top into the bottom. And then I can match sets with using copper foil tape. So this sphere is the battery. It's going to run as the battery. I can phase it to recharge the battery as I add another stack over it. So when I finish with adding the aluminum tape, I'm going to add another coil over it to synchronize the battery on both sides. That will create a power within it. And also, I'm going to use the phase wires to phase the sides. So one is to phase the downward, and one is to phase outward. So I continue a constant flow and a solenoid linear upward. So while the battery is charging, it's also exerting power out. That's DC. So it's going to phase into here, and it's going to phase back to here and make a cycle. And that is going to be deposited into these spheres. These spheres right here are like solenoid coil spheres, stainless steel on the other side. And I'm going to deposit it in here. So when I do make the coil be fat enough to fit the sides. So yeah, and these have rectifiers for its own power that will be using to send Hall effect from here to here, and the wires power sending, and that's also going to synchronize this to induce power. So I'm trying to make it, constantly increase in power and self-generate power. So I can use a Hall effect gun to send a Hall effect to it, and the lightest phase in its vector will cause it to levitate, energy harvesting propulsion. So my name is Jermaine Morton, and I'll be back. So I apply the aluminum tape alongside the surfaces. I can use aluminum foil within and alongside the surfaces of the copper coil. So I applied the tape and the sphere, and I connected the sphere, bust it by phasing the 50-50, half and half. This is like a battery. So here, this is where I take the phase point alongside the surfaces. I phase the wire and phase half and half, 50-50. So one is cathode positive and one is negative anode, and I have to tape the edges to prevent the metallic bond from the top and the bottom. So that goes back in there, and I gotta take the other basket. Okay, so I added the tape to the metallic tape, aluminum, to the surfaces, conductor tape, and I have the rectifiers and the motor capacitors. So the sphere, this is the following part, where these two are, I have to silicon carbide. This one I have to use regular tape, plastic tape around here to protect against the surfaces of the metallic bond. Just as similar, I would have to use aluminum bowl inside of here, just as Eric Lasfith have added helix coil with aluminum ring, and he introduced it with a copper roll bearing, and it moved when the presence of the localization of aluminum was being phased by a positive charge. And when he introduced it to the copper roll bearing, it have rotated. So this is the copper. Pretend that this is the copper pillar. This is the iron flux, which is the stainless steel. This have the copper, which is the second copper that's inside the chamber, and these are the aluminums between this one, and this one. So I'm going to use an aluminum bowl to topple both with two of the same identical aluminum bowls, so I'm going to encapsulate this and sphere this open clearance. I'm going to make a hole so it gets lounge right around, fixed along the surface. I remember I told you I had to filament this in with resin, so my hope is not to, because I don't want to have to tear out the capacitors. I want to be able to remove the capacitors, so I would have to try to find a way to make a mold for a socket for the capacitors in the same arrangement of it around the diameter. My name is Jermaine Morton, and goodbye. Okay, I added the silicon carbide. It's local alongside the surfaces, so I add small gauges of silicon carbide, and now I'm waiting for it to cure. I put it in a plastic glue, and they should cure with the silicon carbide. Then I'm gonna go over it one more time, and then I did the bottom too. And then I'm going to wrap it up and tape, protective tape, and then I'm going to coat the tape in a plastic glue. Then I'm going to wrap it again with foil. Then I'm going to wrap it again with coil. Coil. That's the spear, and that's also the inside of it. These are graphene sheets with copper within it, with a Healy's coil underneath, with a foil underneath, and then a Healy's coil. Okay, so the sheets of graphene for the battery is aligned around here in stacks around the silicon carbide on the laminated sheet. So I'm going to apply tape around there to protect that. Both sides are covered with tape. The battery is in here. See that strip? That strip that goes a line up here, and the strip that goes across here is the battery. And there's silicon carbide right there. So what I'm going to do now is I covered all areas with tape, not leaving one area open. And now I'm going to tape it with foil tape. Here I covered every area with laminator. I also put a strip around here on its other side of the tape, of aluminum tape, so there's more than one capacitor in here. The same way I did this. Okay, so I added one coil over the device. I added a wax sheet paper, and I took the phase out and I fluxed it density. I added this tape with the phase wires out, and I cut the PVC off of the phase wires and allowed it to phase this foil, and then I'm going to wrap this foil around here. And this is the whole effect suspension coil that should move up this way and force the battery up this way. Lenz's law, phase point in, so the coil is phased into the bottom, and it's phased into the top of there, phased in the bottom of there, phased at the top of there. Okay, so I added the tape, plastic tape, to cover over the battery. This is the battery laid out across it alongside. This is the synchronous coil that is going to synchronize the other one, and the other one, and the other one, and the other one. So, and this is the nipple where I have plastic over it. I guess the following top coil. And first I'm going to aluminum tape it, and then the following top coil. Okay, so now the entirety is wrapped up in foil. Batteries are all wrapped in here. The capacitors I have also in here. And now it's time for the copper foil. So this last one, I'm going to add another waxy paper over this copper film foil. And once I add that, then I'll tape it. Then I'm going to cover it with this and leave that one exposed. That's it. It's first capacitive in here. It induces the currents in here, and exchange the positive to here, and that'll flux the density to here, and keep going continually all the way to the base, to the stainless steel central core base. Okay, so I added the other sheet of copper alongside of it, and the other one is underneath, and I have to add some tape to protect the conductors. Okay.